Hello everyone. So I'm just reading a patent right now. I was looking up Paramahamsa Tewari, and I found this patent on, it's called a reduced reaction rotary alternating current generator. Let's go ahead and see if we can look at some photos of this, of what it's showing. I don't really know what these mean. That looks like a magnet of south. This looks like I don't know if it's a magnet, but it looks like it spins. You can look this up for yourself. I'm just going to glance through the photos right now of what's being shared here. A lot of these are the same. That one's different. There's another one that shows the actual magnet. So we have south, north, south, north. I don't know what these are, but we're going to read right now. We're going to read a brief description of this, and maybe some of this will make sense when we do that. So let's go back. Back to this. There's the patent number, it looks like, United States. It does say status abandoned. So let's go ahead and see if we can learn something about this here in this description. I'm calling it a description. It's called abstract. Okay, it's called an abstract. So let's see what this is saying. It's saying a reduced reaction. I mean, already I'm liking what I'm hearing, because reduced reaction, right? I think back EMF or drag, how when you want something to do work and it slows down. And then I think of John Bedini, Tom Beard, and Don Smith. I think of their work, and there's a lot of ways to reduce that back EMF, right? Or that drag when you're putting a load on something. And there's also the loving giving path, which is a whole different way to approach efficiency, right? I am focusing on how to understand the first, second, and third stage. And I don't know if that relates to the loving giving path or not, but I'm trying to understand these stages. So I will be looking deeper into the first stage, second stage, and third stage. And I don't know if those words even relate to the loving giving path, but it's something I'm trying to understand. I keep hearing these words, stage 1, stage 2, stage 3. I don't know what we're talking about. Okay, has to do with something that Rick Friedrich mentions a lot, and I just don't know yet, and I hope I can learn. So we have abstract, a reduced reaction alternating current generator, including a hollow stator core, a cylindrical rotor within the stator, a freely rotating shaft coupled to the rotor, a first set of magnets in which the south pole of each magnet is coupled to the surface to the rotor, and the north pole of each magnet is facing the inner surface of the hollow stator core. A second set of magnets in which the north pole of each magnet is coupled to the surface of the rotor, and the south pole of each magnet is facing the inner surface of the hollow stator core, and a set of silicon steel pieces coupled to the outer surface of the rotor, comprised of individual silicon steel pieces positioned adjacent to and longitudinally in line with each individual magnet within the first set of magnets, and each individual magnet within the second set of magnets. Okay, so I just read this here, and I don't know if you can visualize anything while I'm saying this. I had a couple ideas what I think I heard, but not well enough to try to talk about what I think I saw or imagined. It says synchronous classification, synchronous motors having permanent magnets, synchronous generators having permanent magnets with stationary armatures, and rotating magnets with magnets rotating with the armatures. It says view one more classification. And it says inner rotors, the magnetization axis of the magnets being perpendicular to the rotor axis. Okay. It says what is claimed, and then it has all this. I think we could read what is claimed. You could read this yourself, though. But let's go ahead and read what is claimed. A reduced reaction alternating current generator comprising a hollow stator core having an axis comprised of longitudinally positioned sheets laminated with a high permeability magnetic material. The laminated sheets including longitudinally embedded slots in which a conductor winding is laid parallel to the axis. A cylindrical rotor concentric with and positioned inside the hollow stator core comprised of a high permeability magnetic material. A shaft coupled to the rotor and driven by an external source so as to freely rotate the rotor relative to the hollow stator core. A first set of magnets in which the south pole of each magnet is coupled to the surface to the rotor and the north pole of each magnet is facing the inner surface of the hollow stator core. A second set of magnets in which the north pole of each magnet is coupled to the surface of the rotor and the south pole of each magnet is facing the inner surface of the hollow stator core, and a set of silicone steel plate pieces coupled to the outer surface of the rotor comprised of individual silicon steel pieces positioned adjacent to and longitudinally in line with each individual magnet within the first set of magnets and each individual magnet within the second set of magnets. The reduced reaction alternating current generator of Claim 1, wherein each silicon steel piece is positioned relative to a corresponding magnet to create magnetic circuit through the silicon steel piece and the corresponding magnet such that the magnetic flux emanating from each magnet is guided in one direction into the stator and then guided in an opposite direction out of the stator. Okay, if you want to read this yourself, you can. Like I was saying, here's the patent. I'm not going to keep reading it because I'm just not really visualizing what it's saying when I read that. And it seems like a lot of it's just repeating the same thing. So it's called a reduced reaction rotary alternating current generator. And just looking at this right here, at this photo, which I'll open this one again, it just looks like from here, it looks like I'm noticing the magnets are spaced far away from one another, right? So we have a north, a south, a north, a south. That's the alternating current, right? Is that it's opposite poles going back and forth. I don't know what these are. I don't know if this is the coils where the energy's collected in here. But I imagine that this gap, this big space, that looks like a big gap to me, would allow this to be very efficient. Like when there's a load on it, it's because the space looks very big, I would imagine that there's a possibility that it's not going to slow it down a lot. And it does make me think of something I've read where there's still a significant effect. I don't know what the effect is, but when we have magnets far enough away, when magnets are far enough away that they're not, you can't feel a noticeable back EMF when they're far enough away from like coils or other magnets, but primarily coils, right? They were trying to generate power or charge a battery by running the magnets past coils, that there's still an effect there. And I don't know what that is, but it's something I want to experiment with. When I look at this, I think of that. And I also think a couple different experiments. One is when magnets are very far away from the coils, there's supposed to be a difference between keeping a battery fully charged versus charging it from being very low, like empty or low. There's a difference there. I wonder if having the magnetic field very far away, and I'm not talking about this generator, I just mean with an experiment and putting like an undersized rotor like inside of an alternator, for example, right? If I put a permanent magnet rotor inside of an alternator and the rotor's much smaller, that spinning field, what would happen on the output of that alternator, right? Well, I wonder, could I use that to keep a battery charged, fully charged, instead of charging an empty battery? Can I charge an empty battery with that kind of circuit? Things like that. These are the kind of questions I have. But still having the north-south, north-south, north-south orientation, right? I have a rotor right now, but it has the magnets very close together. It doesn't have them spaced out this far away. Okay, everyone, that's it for this video. We'll see you soon in the next one.